Hi, welcome back to my workshop. This is part 4 of building the 8088 XT PC. After all the boring soldering, we finally get to put this together and switch it on. You can clearly see that it works, but there was quite a few issues with getting it working, mainly the power supply blowing up and caps burning on the backplane. So I couldn't finish filming the first version and I've had to start again. That does mean it won't be quite as dramatic with my reactions, but I'll do my best to recreate how I actually did the testing and the steps that I took, including things that didn't work, so we'll reproduce those. The first thing that we're going to do is quickly look at the parts that we've made in the previous videos. Then I'm going to get the backplane set up and we'll do some testing, make sure that the power is safe coming from the power supply on the backplane before we plug any of our RSA cards in. If all the voltage looks good, then we'll plug cards in one at a time. So let's quickly have a look at what we've made before we get to that point. So this is my test rig. It's hooked up to my LCD so that we don't take up the whole bench with the CRT. I just grabbed a piece of wood. I've been 3D printing some supports for it to stand on, and I 3D printed this back part. This is the power supply out of a Dell PC. It's used in the same way as the other case. We've got this AT to ATX adapter. I have a switch for the ATX power sense and a reset button. One of the things that I didn't read about setting up this board was to get sound out the speaker, we need to have a jumper to loop the sound in and out. Otherwise, the sound is just going out to a normal speaker. I also mentioned about this jumper, and when I put it on, I actually didn't put it on, I only put it on one leg. I still haven't worked out what to do with these switches yet. If I change them in the wrong way, it doesn't boot up. So I think I'll leave that because everything is working. So we have the 8088 card, we have the graphics card, the IDE controller, and I grabbed another compact flash adapter from the other PC so that we don't have the long cable looping around everywhere. And then we have the Adlib card, and the bottom is the backplane. So like I said in the intro, the morning after I did all of the first filming, the tantalum cap on a 12-volt line let the smoke out. I don't know if that was because that went or if the other power supply went, so we're not using the other power supply. I brought caps and I replaced all of them on the board. At the same time, I cleaned up with Deoxit all of the edge connectors because I was having just random problems with it not working. Now that we've had a look, I'm going to take it all apart. We'll go through all the various steps of testing before we get to the point of plugging things in. So this is the lovely backplane that I bought from eBay. I think it was about £25 plus shipping. It has the XT keyboard interface, but we won't be using it, and these lovely tantalum capacitors. So the one for the 12 volt is the one that produced the smoke the next day after filming. Thankfully, nothing is using the 12 volt on the board, so there was no damage done to anything. As you could imagine, the next morning when I turned it on and the smoke came out and it turned off, I thought the worst and was really unhappy. As I went through and checked things and realized that I hadn't actually damaged anything that I had made, I was quite relieved. So what I want to do before we plug any cards in is check that we are getting the voltages across the board. Now we've obviously got a nice power supply, so I just want to check that the voltages are good and that there are no shorts across those voltages. So if we just put continuity on, I have the diagram on my phone. I'm going to put my probe into ground on the power supply, and we look down the diagram and we have ground at the very top pin and the very bottom pin of the left hand side, and then we have 5 volt, which is 1, 2, 3 down, so we don't have a dead short on the 5 volt. Then it's IRQ2 minus 5 volt, we don't have anything connected to minus 5 volt, minus 12 volt, and plus 12 volt. And third from the bottom is also 5 volt. So we don't have any dead shorts. So if we check the power from the connector, red is going to be 5 volt, which is the third from the top, and the third from the bottom. Yellow is 12 volt, which is the 9th pin. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have 3 more 5 volts at the bottom. So they're all good. And then we've got a -5 and a -12. So the brown is -12, and the blue is -5, even though we don't have -5 coming from the power supply. So it looks like the voltages are present and are getting through. So I feel happy enough to turn this on, and then we can actually measure the voltages. On the power supplies, you have the green wire, and to turn on an ATX power supply, you want to short the green wire out. When you get these adapters, they normally come with a cable that goes to a switch on the front of the case, and I just soldered a mains switch onto that wire, but it doesn't actually carry mains, it's just like a sense. So we can use that to switch it on. So I'm going to put my ground back into the harness. So I've set my multimeter to DC volts, and we can turn the power supply on and check those voltages. So the power supply is running. So third from the top should be 5 volt. So we have 5.1, but there's no load on here. Then we miss one. We shouldn't really be getting anything on the -5 volt because we don't get it from this power supply. There we have -12 volt. And then we have 11.8, so the 12 volt's a little low. If we check the third from the bottom, we've also got 5 volt. So I'm happy that we're getting the correct voltages going to the ISA bus. So I guess really we could try plugging something in and seeing what happens. I don't really want to plug the processor board in, so I'm going to try the graphics card and see if the graphics card just does anything. The graphics card is easy to replace. So this is our Trident TVGA 9000i graphics card. I set the jumpers on the board so that it will work in an 8-bit ISA bus. This card can work in 8-bit or 16-bit. It doesn't matter what slot that we're going in, but I've just got a habit of plugging them into the same slots. There we go. And I've got my little 3D printed bracket at the back to hold that in place. I'm going to plug the graphics into the monitor just to see if that does anything. We've just got our graphics card plugged in. I don't know what it's going to do. Let's just switch this on and see. So our power supply is running, but the graphics card isn't doing anything. Sometimes they might still display like a logo, but in this case it needs the processor. So I guess there's no way around it. We need to plug in the processor card and just try it. So I'm plugging the card in the same way as when I first did it, which was to not have the speaker connected. So we'll just secure that in place. So I have the reset switch for the card. Just make sure they're all seated. This is the part that we've been waiting for. Will it actually work? Let's switch it on. So we have power light on the board, and we have green light on the monitor, and we have display. So we're booted into the BIOS. Let's press. Oh, I haven't got the keyboard connected. So let's just see what it does. So only CV20, no mass coprocessor, EGA, VGA, video BIOS is present, serial ports none, parallel ports none, floppy drives none, total conventional memory, 640K, boot failed. There's no hard drive connected, but it worked, amazing. It's actually booted. Now it worked easier this time because I've cleaned up the backplane and cleaned up those sockets, whereas before it took me a couple of goes of reseating the cards. And it was also in the desktop case that you saw, the backplane wasn't supported very well. So I was pushing cards in and the backplane was flexing. It just wasn't very good. Now I'm a lot more prepared. So the backplane is secured and the edge connectors are cleaned up. So it's working a lot more reliably. So that's really, really good. But I was a bit like, there's no beep, there was no noise. What I found was that you need to plug in a jumper for the speaker. So this 4-pin header under the dip switch is for the speaker output. But if we don't connect the speaker up to that, the sound is just like going nowhere. So we need to put this jumper on the bottom 2 pins, and that's a loop back for the speaker. So now the internal speaker will work. Now that we've got that jumper on for the speaker, let's try switching it on again. So there's the post beep and the Intel that you might have heard on the LGR video. Okay, let's switch this off and plug in the PS2 keyboard. So now we should be able to configure some, like look at the configuration of the BIOS. So we'll press F1. So there's no like graphical interface or anything. So H, and we can set the default clock frequency, change the floppy drive type, change the print current settings, save changes. So let's just do P. So clock frequency 9.55, floppy disk drives none and none. If we do C and H, so C is the command to change the clock, and we've got 4.77, 7.16 or 9.55. Well, we're already running at 9.55. So we'll go return and W, save changes and exit. So now it's going to try and boot from the hard drive that's not there. So I'm going to get the hard drive card and I'm going to set that back to how it was when I first tried this. So this is our IDE controller, and we've got these banks of jumpers. And if you remember on the video where I made this, we set the jumpers up to match the instructions. So I'm going to plug them in now that I've put the jumpers back to how they were from the instructions. And everything is switched off. We also need power for the compact flash. I just made up a simple header for this. So let's try this again. So this was how it was when I first tried it. But it just sits there saying booting to Oz. We didn't get any kind of on-screen prompt saying that it had found a hard drive. And I wasn't quite sure what was going on. So then I looked at the picture on the other side of the instructions, and the picture showed that those jumpers were back to front. So I want to just change all of these jumpers to be opposite of what they are. So that was how the jumpers looked on the picture, not the instructions. Let's try this. We have power on the compact flash adapter, so testing the RAM. Now we get this XT-IDE universal BIOS. It pops up and it's now patched in the hard drives from the compact flash. And we're booting to MS-DOS. I haven't configured any of the config.sys or auto-exec. I'm not quite sure what I need to do with the upper memory stuff. It said to run high mem and then set DOS equals high UMB, but then obviously high mem will not run on this processor. So I'm not quite sure. And the things that I've done so far on the switches stopped it from booting. So that could have been because something was conflicting, maybe with the XT controller. I need to spend a bit more time. The main thing is that we've booted from the compact flash into MS-DOS. And all the files are there. So I have a directory called bench2. And there's quite a few different benchmarks on there, but we've got Checkit. So if we run Checkit, see, that's working, it's great. So I think this is a German version, unfortunately. It's happy with everything. I think this is the one that we need to do, CPU and NPU. So it's just running the performance tests. It's recognized that it's a V20 at 9.55, and this is our IBM XT, and this is our PC with the V20. And I've looked up the results from other systems, and that matches. So we're pretty much spot on for performance. So at this point I was really happy. We've booted from DOS, I've got the IDE working even though those jumpers were the wrong way around, and everything seems to be working. I was really happy. The last step is the good old OPO card on the horrible white PCB. So let's plug this in and make sure that we still switch on, and then find something that we can use to test the Adlib Sound. Still haven't configured that, so the first program that I ran was Prince of Persia. So actually the first thing that I tried to run was Warp 3D. Unfortunately, this program requires a 286 or better, so I couldn't run it. So graphics mode, we've got VGA. We can run that, or we could run EGA. So let's just leave it on VGA. Input device, keyboard. Sound device, Adlib. I think we can do Adlib or internal PC speaker. We'll leave it on Adlib. Music synthesizer, Adlib. So is it going to work? We know that it works, but is it going to work? We have music. So again, I was incredibly relieved when I heard the music. The one card that I thought wasn't going to work was that Adlib card, but it works great. So there we go, we've completed the goal of making our own 8088 XT. We've got a couple of cards that are kits, and then a couple of parts that we found on eBay. Obviously we need to look at putting it in some kind of case, but XT cases are quite expensive. I could try to mod an AT case. Maybe I could put the 3 cards at one end, and then cards that don't have any I/O I could put in the section that we can't see. There is one on eBay for about £20, which is a nice little beige box. Or I could carry on with my 3D printing. Let's just come out of there. I'll just reset it. So now that I've got this far, obviously I couldn't stop, and I found 2 more designs where I could get the Gerber files. So one of them was for a CMS, a creative music system, and I've got the boards and some of the chips on way. I haven't looked at any components like passive components. And then I also have a floppy controller, and the floppy controller can do floppy and serial, and you don't have to put all of the parts in. I've got the board on the way with the other one. I've got the floppy controller is already here, but again I haven't looked at the rest of the parts for that. I did manage to find a high density disk drive for quite cheap, which was really lucky. So we can add the floppy drive controller and also the CMS, the creative music system, to see what that's like. I was bidding on an actual creative card on eBay, but they're going for £100, £120, really expensive. We do have the Adlib, and with the CMS, I think we'll have everything covered for this time. Over the weekend, I brought Planet X3 so that we could have a look at that. And we've got various different modes, so we could do CGA. So we should be able to run, I think, any of these modes that go out that will work on the Trident. So I think we could do maybe number 6. And again, Adlib. So that's running in CGA. It looks like it's only 4 colours. So now we've got EGA. It's really slow to update that screen, wasn't it? It doesn't look particularly good in EGA. So I'm wondering if it's trying to do a mode that this Trident card doesn't like. Come on. And then we can do VGA. See, that looks loads better in VGA and that runs so much quicker. So it runs really nice. I found some instructions on the NUXT website that explains how to use the dip switches and move the memory around. Now when I tried this before, I had all the switches off, and if I put switch 1 up, which was what the picture showed on the main website, it wouldn't switch on. I knew that the XT-IDE was in the range that switch 3 was working on. So after some experimenting, switch 2, 4 and 5 I can switch up and the system boots okay. I'm sorry about all the noise in the background. I wasn't expecting to be filming, so printers and things are running. So we'll just let this boot up. So I made a simple menu in the config.sys. If we go to do not use, it boots as normal. If we type mem, we have 640k of conventional memory, no upper memory, 580k free. Now if we choose the option to use upper memory, we get all this extra stuff. And there's one program that tells the system what memory address it can use in the upper memory block. Then we have this program called DOSMax, and DOSMax is loading the various programs that we're using inside DOS into the upper memory area. If we type mem now, so we have 640k conventional and 128k upper. Because we've got 3 different banks that are split, we can only use 96k maximum. Well, we can see that we've got 9k from the programs that we've loaded moved up to upper memory. So it's not much, but we've gained 9k in the base memory. As I'm loading stuff in config.sys, more things can be put into the upper memory area. So just a quick add-on now that I've figured out how to use the dip switches and that I found the DOS utilities that allow me to take advantage of that upper memory block. Now back to the normal video. Here we are at the end of this journey. We've got through all of the boring soldering. We finally put together this 8088 XT PC. It's working really, really nicely. The Adlib card is working, graphics look great. We've got many options for the different graphics modes that we can use. When the Creative Music card arrives, I'll make a video for that, and also for the floppy disk controller, I'm going to work on making some kind of case for it, or maybe buying something and modding it. So there'll be some more videos that will cover this at a later date. Thank you for watching this series and for subscribing to the new channel. I've got loads of projects that I'm working on at the moment, which are going to be featured on here. I'm going back to the 3D printed case for my Mister system and also Raspberry Pi. I'm just working on that. I'm also trying to work out all the little issues that I've been having on my CNC for making printed circuit boards. So loads of retro programming and geeky projects that will be coming up on later videos. So thank you for watching this video, thank you for watching this series, thank you for subscribing, and I'll see you all soon.